Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to another video on my channel. In today's session, we are going to be revising Learning Objective 17 FRQ questions 44 to 55. This is a much requested video on solving trigonometric equations and identities from lesson 11.5, especially coming out for my grade 11 advanced students. So let's get started with today's session. Okay, so let's solve question 45. So here you can see that this is a quadratic equation in sine. So if I take sine theta as x, then this becomes 2x square minus 3x minus 2 equal to 0. Do you see the quadratic now? So we can find the sum of roots and product of roots. So this can be written as 2x square minus 4x plus x minus 2. So I can take the common factor from these two and these two separately. 2x is common, so x minus 2 left. So I can write 2x, now I'm collecting 2x plus 1 and x minus 2. So the two factors using zero product property are 2x plus 1 equal to 0 and x minus 2 equal to 0. So x equal to 2 means sine theta equal to 2. Is it possible? Maximum value of sine theta is 1. So this is not possible. So no solution will come from this part of the inequality. We reject it. And now we focus here. So 2x equal to minus 1 or x is minus 1 by 2. X is my sine theta. So you can use your calculator. Use inverse. So theta will be sine inverse of minus half. That means you will get the value of theta as 7 pi by 6. So I will just put it in the box. This is particular solution. Now in this question the quadrant is not mentioned. That means we have to give general solution. So the general solution would be given by theta equal to 7 pi by 6 plus 2k pi. Now why we add 2k pi? We add 2k pi because we are giving all the possible solution. Here k is an integer. It can be any integer, positive, negative, 0. So 2 pi being the period of sine theta, that is why we add 2k pi. Or if you want to just convert this into degrees also, you can give your answer as one more value 7 pi by 6. You will get this on your calculator. So these are the two values in radians, and if you want to convert it into degrees, it will be 210 degrees plus instead of 2k pi, now 2 pi is 360, so 360 degree times k. All we can convert 11 pi by 6 into degrees, so that will be 330 degrees plus again 360, because 360 degrees is the value of 2 pi, and then we add k, which is any integer. So this completes question 45, where we have given the general solution. Okay, in a similar way, try question 46. So in this slide, I have given you the step-by-step solution to reach the particular solutions, which are 7 pi by 6 and 11 pi by 6, or 210 degrees and 330 degrees. And we have also seen in the last slide how we convert this to general solution. So now here I have provided you the answer key. I hope you were able to solve this question similarly using quadratic equation. So here you see cos square and sine, both are different. So definitely we will replace cos with sine using Pythagorean. So put this here and then simplify. So this is 2 times 1 minus sine square theta plus 3 sine theta minus 3. Now we want to convert to a quadratic equation in sine. So let's take x as sine theta. So this on simplification will give you minus 2 sine square theta plus 3 sine theta minus 1 equals 0. Let's make it positive. So 2 sine square theta minus 3 sine theta plus 1 equals 0. Put x. So 2x square minus 3x plus 1. It's a quadratic. So we split the factor using sum and product. So the two factors are 2x common, so 2x minus 1. 2 we have already taken, so only x, and then minus 1 times x minus 1. So here, if you do the factors, so it is 2x minus 1 and x minus 1 equal to 0. So therefore, the two roots will be x equal to 1 by 2, x equal to 1, x is sine theta equal to half, sine theta equal to 1. So theta is coming out to be pi by 2 particular solution, and here theta is coming out to be pi by 6, also 5 pi by 6, two particular solutions from here to from here, and then this one is your general solution. That completes question 46. Now let's solve the last two questions, 54 and 55. So here I will use the double angle identity for sine. So this will be 2 sine theta cos theta and 2 sine theta here. Now I will move it on the other side and collect common. So this will be moved. So 2 sine theta cos theta minus 2 sine theta equals 0. Let's see what we can take common. So 2 along with sine theta will be taken out. And I'm left with inside cos theta minus 1 equal to 0. So 0 product property, 2 sine theta equal to 0 or cos theta minus 1 equal to 0. So from here sine theta is 0 or theta is 0 degrees. So we will now give the general solution. This is particular solution. So general solution will be theta equal to 0 plus pi k, where k is any integer. Now will you get a solution from this thing? The equation was in sine. So can cos give you a solution? No. So we will ignore this part. So this is my final solution. Theta equal to pi k, where k is any integer. Let's solve this one. Now here if you see, there are so many different ratios, cos, tan, cos square. So we'll try to convert everything into one. So let's convert everything into sine cos. So I use quotient identity. Tan theta is equal to sine over cos, and I use Pythagorean identity. So I will put tan theta as sine theta divided by cos theta. This is quotient. And when I do that, some cancellations are going to happen. And here in place of cos square, I will put 1 minus sine square theta or Pythagorean. Right side is same, no change. So this goes. So here I have sine theta minus 2 plus 2 sine square theta plus 1 equal to 0. Rearrange and it will be a quadratic equation in sine. So this is what we get. Now let us assume x to be sine theta. So this quadratic equation changes to 2x square plus x minus 1. This is easy for us to factor because we know sum and product will give us 2x square plus 2x minus x minus 1. Take common factor. So in these two, you have 2x common, inside x plus 1. In these two, minus 1 is common, so x plus 1. Now you have the same bracket, so x plus 1 times 2x minus 1 will give you the answer. Now I have less space here, so I will continue this on the next slide, and we will use zero product property to give the final answer. So in the last step, we stopped at 2x minus 1 equal to 0, giving you one solution, and x plus 1 equal to 0, giving you another solution. So x is 1 by 2, x is minus half. Now x equal to 1 by 2 means sine theta equal to 1 by 2. Use your calculator. So sine inverse of 1 by 2 or 0.5 will give you two values, two particular solution, 1 pi by 6, another 5 pi by 6. This will give you your solutions. We will ignore this one because it's a negative value. So therefore, the particular solutions are the first solution pi by 6, the second solution 5 pi by 6, and for general solution add 2 pi k because the period is 2 pi or 360 degree where k is any integer. So this is your final answer key for question 54 and 55. That brings us to the end of today's session and completes learning objective 11. If you found the video useful, do give it a thumbs up. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.